Welcome back, everyone. This is the last video for, it's page 139. It's for Module 1, Topic 3, Lesson 3. It's Activity 1, and we're continuing it. Activity 1 continued. Consider Selena's statement. Selena says, write a 0 at the end of a number to multiply it by 10, and 2 zeros at the end to multiply it by 100. So 3 and 2 tenths times 10 is 3 and 20 hundredths. 3 and 2 tenths times 100 is 3 and 200 thousandths. Explain to Selena why her reasoning is incorrect. Please pause and think about that. Okay, so what's going on here with her? First of all, this is 3 and 20 hundredths, but she started with 3 and 2 tenths. Is 3 and 2 tenths the same as 3 and 20 hundredths? Here she started with 3 and 2 tenths, and she ended up with 3 and 200 thousandths. Well, didn't we say that we can add zeros at the end after the decimal and after the last non-zero number and not change its value? Okay, so when she multiplied by 10 and 100, her answer didn't change value. Okay, she can't just add zeros on. Explain to Selena the similarities and differences between these two number sentences. So we have 32 times 10 is 320. 3 and 2 tenths times 10 is 32. 32 times 100 is 3,200. And 3 and 2 tenths times 100 is 320. So, well, I'm just going to draw a line down right here because I see these are both multiplying by 10. These are both multiplying by 100. So what's happening when it multiplies by 10? Right now, the decimal point is right here at the end. And in the beginning here, our decimal point is here. So when we multiplied by 10, our decimal point seems to have shifted over and ends up with a zero behind it, a decimal behind the zero. Does that happen here? It shifts over from 3 and 2 tenths, it shifts over 1 to just 32. So we could say the decimal point moved right. You have to write small, guys. One place when multiplying by 10. So what does it do here when we multiply by 100? The decimal's here, and now it's here. The decimal was before the 2, and now it is at the very end. So the decimal point moved. This time it's 2 places to the right. Because I should have written this just like this one. Because it is a times 100. There we go. That'll be good enough. Okay, go ahead and pause it. I have to hold it like this for a minute because of the way the light is tonight. I don't know why it's like that. When multiplying decimals, the number of decimal places in the product is equal to the sum of the decimal places in the factors. We've actually already talked about this. It's coming in formally here. I multiplied, Camilla says, 3 and 65 hundredths times 4 and 22 hundredths on my calculator and got 15 and 403 thousandths. There should be 4 decimal places in the product, so it must actually be 1 and 5,403 ten thousandths. Explain to Camilla why the calculator is correct. So I think to do that, we're going to have to look kind of at that first set of multiplication. 2 times 5 is 10. Carry a 1. 2 times 6 is 12 plus 1 is 13. And then 2 times 3 plus 1 is 7. So when we're multiplying, we would do that, and then we move over to this number and multiply it by each of those. And when we do, we put a 0 here. And then once we do all that, 2 times 5 is 10. 2 times 6 is 12 plus 1 is 13. 2 times 3 is 6 plus 1 is 7. So we essentially have the same thing, which made sense because they were both 2's. Now we're going to work with the 4. Our answer needs to start right underneath there. So this time we have 2 trailing zeros. 4 times 5 is 20. Put a 0, carry a 2. 4 times 6 is 24 plus 2 is 26. Carry a 2. 4 times 3 is 12 plus 2 is 4. Let's add. Okay, so look how it ends. My number ends 154,030. If I didn't have any decimals in it at all, it ends in a 0. So why is the calculator correct? The decimal point, we have hundredths times hundredths. So that's going to be a 1 with 4 zeros. So our answer should be in the 10,000ths place. Same with 1, 2, 3, 4. 4 numbers after our decimal. So 4 numbers after the decimal would make it here. And if we used estimation, let's think about this for a second. 3 and 65 hundredths is close to 4. 4 and 22 hundredths is close to 4. Our answer should be somewhere around 16. 15 and 403 thousandths is close to 16. This one isn't. This is 1 and 5,403 thousandths. So this one has to be correct because it's closer to 16. So when you guys enter this into the calculator, if you did, which you guys aren't using calculators on this unit, the calculator will cut off that final 0 because it's a trailing 0. It's not needed. It doesn't change the value of the number. If 15 and 403 thousandths is the same as 15 and 4,000 30 10,000ths. This final zero isn't needed. It doesn't change its value, so the calculator is not going to show it. So, and that's why, so the calculator doesn't show the zero in the 10,000th place. Oh, look at this. How could estimation have helped? Oh, we already did that one. 4 times 4 equals 16. So, with estimating, see how my brain went right to estimating? I've been through this lesson previously. I even have another sheet all already filled out right there. But as I was thinking down through here, that's just the way my brain thought, like right away. I was like, oh, what if we just did that? So, and then there it was. How about that? With estimating, I would have known the answer should be around 16. That's your comma. So 15 and 403 thousandths is close to 16, but 1 and 5,000, so what was it? 5,403 is not, because that's near 1. Kind of 1.5. This is 15. 15 is closer to 16. Sorry, is not, I forgot one word. It's not reasonable. It's just not reasonable. Makes no sense. Remember at the end, I always say, ask yourself, does my answer seem reasonable?